Now we have the other microservices subscribed to our uh, tips.processed events. So let's first go ahead and let me explain the moderation microservice. Yeah. So we connect to the NATS stream that is running. We subscribe to the tips.processed event, and then we unmarshal our data. So now what happens here is if the tip is NSFW on the console, it shows that flag tip routed to Discord. Now what happens is we set the tip to Discord as well as on the streamer dashboard, and the streamer has two options: either to just show it on the screen or just silently kill the notifications. Now let's go to main.go maybe. Before I explain you the code base, let me show you how exactly it works. Yeah. So I have opened a tipping page. This is the URL that the streamer provides to the viewer. Now, as soon as you load this page, the first thing that happens is a get call to slash API slash streamer along with the streamer ID. Now, in response, we get this streamer tag, that is the name of the streamer. We get the support title, that is whatever the title they want over here. We have the total goal, and we have the completed goal. Then we have the live link. The live link is for this. They can update it and it will show their live stream in an embedded format. Then we have the UPI ID as to which the payment will be made, and we have the minimum tipping amount. So minimum tipping amount check has been set up at two places at the front end, but somehow if someone tries to bypass the front end, back end check as well. We initialize the payment. Okay, so now we send a post request with the payload as amount, our message, our name, and request ID. This is a UUID generated on the client side. Now, the reason we generate this is to set up a sort of idempotency so that multiple payments to a same request ID are not possible. And we have the streamer ID right here. In response, we get the UPI deep link. Now, so we are sending the client key in the note, and we get a is false flag, is paid flag. So when you pay, it turns true. We have the client key. This is the client key is generated from the server side. I'll explain how this is generated because I have set a special way of generating it. And then we have a support key that you could generate. That is generated. This is also generated on the server side. I'll explain you how the support system works. So basically, support, we store your transaction in local memory. So if you want to put a support request, you have to go from the same browser where you made the payment, and you send a support ticket. So this is sent on the Discord channel of the streamer. So there the moderators can look into this. We have it right here. So we'll go to that function. We have the streamer.go. Okay, so this is the struct for the support. It will have the title, it will have the total goal, and it will have the completed goal. Then in the response, we'll send the streamer ID, we'll send the streamer tag, we'll send the support tag, we'll send the live link to their YouTube or Twitch, whatever they want. Then we are sending the UPI ID and the minimum amount. And then we are performing a database lookup. We have the tips route. In the tips route, we have handler.create tip. We'll go to that. So this is the struct for creating the tip, and this is the response to that. We send a create tip function. This is the request. We get our parameters from the request, and if the minimum amount is set as a environment variable, if the amount is less than the minimum amount, we send back it with an error. Else, we do a database lookup. That is basically we are checking the idempotency right here. So for that client key, if it is already in our table, then we send it back with an error. How the server generates the client key. Client key is a 32-digit key, of which the first 8 digits are the streamer ID. The next few will be in this order: 2 digits for the date, 2 digits for month, 4 digits for the year, 2 digits for hours, 2 digits for minutes, 2 digits for seconds, and 3 digits for milliseconds. So now we are left with 7 empty spaces at the end of the client key. So now these 7 are cryptographically generated in a random manner. Every millisecond, for every streamer, we can have 10 to the power 7 unique client keys. And at this stage, I think this is more than enough. Now we have the handle webhook thing. I'll explain this later. And now we have the support using the Discord to send in the support ticket to the streamer channel. That's worker basically updates the goal amount. Let's say initially 100 was paid to the goal. Now someone pays maybe 50 or maybe 100. So this microservice adds that amount to the updates this amount in the database. Now what OBS engine does is OBS engine just pushes the tips to the OBS to OBS. Now how basically OBS works here. Before starting this project, I did not know how overlays worked in OBS, and especially for these tipping, like for example stream elements or Twitch. So I thought that I'll have to make a app sort of and then do a screen capture of that. But I found that this is pretty simple. You can just set up a browser source in this, and the browser will go to a specific URL and it will fetch all the content from there. So this is what it does. It publishes to that URL, and the OBS client just fetches from that URL. We have a hash map saving all the clients. The current issue with this is that every microservice has to do a separate database lookup to verify everything. But in the future, what I'll do is, along with just a success message, I'll publish everything that is required, like is NSFW serve overlay server side events SSE. So now what basically this is just setting up SSE for the OBS stream. Now there are two places where we set up SSE in this project. The first one is when a viewer pays, and to get the confirmation message, we set up an SSE up to the point that we get a payment success. And in the second place where we set up SSE is the connection between the server and the OBS. So when you close the OBS, this connection gets dropped. We are setting it as event stream. Now this is setting it up as an SSE. So what happens in moderation? We read from the event stream, and it just tells you that the tip is blocked and it is routed to Discord, as well as it is available on the streamer dashboard to do further yes or no with that. Now here we have the front end SSE. Now this is the SSE that is responsible for managing the payment page. Now we have the dash updates. Yeah. Now the dash updates is for the streamer dashboard page. So once you have the streamer dashboard, you fetch all of the contents from the database. You just send in the your streamer key, and it fetches everything from here. Now how this happens, I'll explain that. But right here you can see we have the verify access middleware function everywhere. So you cannot access this if you are not a streamer, if you are not authorized as a streamer. This is the contact us. This is the simplest microservice. We have a contact us page. So you can just type in whatever you want right here, and you can just send a message. So what it does is this saves it to our SQLite database. So this is simply the contact us microservice. Then we have the authentication service. Now what does our authentication service do, and how authentication works? So I'm using a simple Discord OAuth for streamers to just log in, because Discord is something that every streamer almost uses. So this is the easiest way to set it up. We redirect to Discord, we get our access token, we get our refresh token, and then I set up a JWT authentication right here. The reason why I went ahead with JWT is to reduce the database read load. So with this, we can just perform the JWT verification on the CPU as the request arrives, and we can keep the database untouched. This is the get overlay token handler. I'll show you the streamer page as well, and then these rotate token handler, get overlay token handler will make sense. Now this is the main package for our Auth microservice. You can see right here we are using JWT, and we are using sessions as well. So till we assign them a JWT, we are storing the current session state using Gorilla. Then we have the Goth library. The Goth library is for setting up Go authentication. This is actually a pretty good library with claims thing, claims and pending claims. So right now in my model, you cannot just create a streamer ID till I get a way to package this for individual streamers. I'm trying to get in contact with a few streamers so that they can start using this. So as long as you don't have a master password, you cannot log in into it. So this is the pending claim. That is, you click login with Discord, and you get everything back, but the JWT is not generated. The JWT is only generated after you type in the master password. Begin authentication. This is more about OAuth. So if you are already familiar with OAuth, you will just understand this in a breeze. we do a begin authentication. We send it to the Discord. We get a callback URL that callbacks to our server and provides that with an access code. Now we get the access code and we issue the JWT from here. Now quickly let's hop on to the front end. Then we'll go ahead with the app. So now this was the back end. First let's show the normal viewer page. Then we'll go ahead for the dashboard. Yeah. So now we have a checkout route. We have a contact route. We have a disclaimer route. This is just basic static pages. We have the tips route. In tip, we are just sending this as a request, and we get the response for that. And this is setting up idempotency key. So till a transaction is not completed, we do not change that key. So that means that if a duplicate request is sent, it is sent with the same key. This is just simple stuff. Similarly, we have the checkout page. Now the checkout page is where the SSC thing occurs. I took a look at the logic, but the UI is entirely AI generated. I was learning front end development, but I did not want to spend too much time learning front end development, so I just asked AI to generate the entire front end. Then we have the admin dashboard. Admin dashboard has a few pages. We have the claim page, that is the page where you will enter your master password. We have the dashboard, in which we'll have three sub, or you can call three tabs: the ledger, the OBS alerts, and the settings. Then we'll have the obviously the login page, and we'll have the overlay page. This is where the this is where our server pushes the OBS alerts to, and this is where your OBS client will subscribe to. And now let's get to the app. Obviously, once again, I don't know app development. I didn't know app development. Now I do know a little bit, but yeah, the most of the code here is generated with the help of AI. So I'll just explain how everything happens, and you can go and you can just see the code for yourself. So we just extract the notification from Google Pay, from Phone Pay, and this is the testing version. So we are also extracting it from WhatsApp, because for debugging I was using WhatsApp notifications. And then this is queued offline in a SQLite equivalent database for Android. And then we have a background worker called work manager. Now what work manager does, it is goes through our database. It sees if any of the tip that has been paid is not acknowledged by the server, and it sends it back to the server unless it gets an acknowledgement true. Now work manager does exponential back off. So in case you don't have a network of something, it will try after 15 minutes, after 30 minutes, after 60 minutes, and it exponentially increases its TTL. This is the QR scanner screen. So what is this? So basically, when you are sending a post request, that this client key has been paid. Now anyone can send this post request. So we have set up a bearer token in this, and to fetch this bearer token, instead of typing the token key by key from the website to the app, we just scan the QR code. So in this video, we took a dive into the code base, understanding the architecture and how everything snaps into place. In the next video, I am going to show how I deployed it on AWS EC2 instance, and in case it becomes a massive hit and gets thousands of viewers every day, how I would scale this system, and also how to deploy it at home on your home lab or a simple Raspberry Pi. Thanks for watching and stay tuned for episode 3.